Okay, well, no, we can continue for now. Okay, so as we have done before, the same kind of configuration, but let's continue with another one. Just the color, the same way. Now here it is. Okay, this is the mapping that we are doing. Okay, so what are the requirement, and that's the thing. Okay, so we are working with the Cisco System Packet Tracer and classic IEEE spanning tree protocol that we are going to use it over here. The behavior as implemented on the Cisco Catalyst 2960. It means that STP, the spanning tree protocol that we are going to do over here, which is on the device, the Cisco Catalyst 2960. Now here's what will happen in a triangle topology. Okay, so it's try to create the triangle topology. For that we have to take a switch which is 2960. So I will go with the control and then the three switches to create the triangle, because the STP, where the loops create itself, when the loops create itself, to STP to prevent it. Okay, so for that reason we are creating a loop. Okay, a kind of loop for this. Okay, so rename on this. This is switch 3. Yeah, here it is. Let's make connectivity to devices to this switch 0, switch 1 to switch 2, switch 3 to switch 2. In the same way from switch 3 to switch 1. Now as you can see, it's a kind of loop. Okay, not a loop you can't see as you are wondering like it's loop as I'm telling, but it's not exactly loop. When it going to be connect itself, after the 30 second it will going to test itself, and end of that the one will going to pick that will going to be make itself in a blocking state. As you can see right here, the orange F01 on the switch 2, there's the F01 interface which is right now in a blocking state. What was happening initially, the all interfaces was orange at that moment. So the thing was that we call the listening and learning. Okay, so listening part take 15 second, and learning part is also take a 15 second. Overall that we would take the 30 second of yours. So thereafter that will elect the root bridge that will going to find which interface is going to be um, uh, elected what we call designated port, or a blocked port, or root port. This kind of ports that we do use in the terminology that we do follow in this context. So here it is all. Okay, so in this all configuration there's nothing about that we have to make it over here. But the thing is, what we are going to make it, if I just going to hide this thing, let me just do make changes over here. Suppose that there's nothing about this indicator. So if I will go in preferences, I can turn off this thing like so. Link light, if I will untick this one, and okay, so I will back it over here. As you can see, there's nothing about the indicators, the link light is not blinking right now. Okay, so what the next thing that we can understand from this image? Uh, okay, so what is the uh, STP? STP is spanning tree protocol who prevent the kind of the storm that we call the broadcast storm. As we know, the nature of the switches is broadcasting. Okay, so if from somewhere the packet is coming, and the nature of, as I told, the nature of switches is broadcasting, so definitely that will going to broadcast each and every port, excluding which is where it's coming from. Okay, which ports, by which port is coming, excluding that port, that will going to forward that all further ports. Okay, so yeah, that's the nature of the switches. By default, that's forward the packet. So suppose that the switch 1 which is receiving on F01, you have no need to bother for that, like it was a blocking switch, blocking a port. Don't think about that. You have to just think like a fresh switch, a fresh. There's nothing about indicators or blinking light. They're all not working over here. So what you have to think is, this is the switch 2, and on switch 2 there is F02, F01. So at that moment, suppose that the switch 2 is receiving the packet on F01, so definitely that will, the nature as we know, it forward the packet on each and every port, so definitely that will going to forward the packet or at F02. So when it will go to this one, the same thing, that's the same story will going to do with the switch 1 to switch 3, and switch 3 will going to do the same thing to the switch 2. Okay, it means that the whole thing is going to be do like circle, the round. It means that one single message is going to broadcast in a same way, one to another. Okay, so there's nothing about the stop. So definitely at somewhere it's going to be cast is going to create itself. Okay, this is the broadcast situation. If the packet is going in around and round, so this is what a broadcast. A frame is going to, not a packet, what we call the, usually we call the packet, but in real the packets that we consider on the layer 3, but here it is whatever the frame is going all around it. So it's going to create at a point the kind of loop. Okay, that we call the broadcast storm. Okay, so STP, the spanning tree protocol, who do prevent this thing. Okay, so STP prevent this thing. So you will going to see whatever initially you were saw, this all like thing like blinking lights initially in all orange, that was the listening and learning part, and end of that one election will happen internally on the basis of the priority number, and the election is important. What is the election? The root bridge election. Who do manage, who do going to do, who do whole understanding of the frames, the storm, who do control the storm exactly, what we call the root bridge. Okay, so in order of doing the STP, so the root bridge election is highly important. So how the all switches initially they all think I am the root bridge. Okay, so the all switches will think like I am the root bridge, so they all broadcast the frames and try to not a frames exactly, they try to send, and they frequently send the BPDUs. Okay, so the BPDUs a kind of a unit uh, who will going to play the game in a context of election. Okay, so each 2 second the BPDUs BPDU messages will going to send from each and every switch initially. So for the election, this is the important for the election. So initially each and every switch, as I told, that think like I am the root bridge until the election happen in real. Okay, so the frame contain each and every each other's, like the priority number and the MAC address number that we call the bridge ID. Okay, so the election, which is based on the bridge ID, in bridge ID. Okay, so let me play this all in a different way. Okay, so the switches have the bridge ID. Okay, in bridge ID there's two identities that we call the priority number, and the second thing is MAC address. If the priority number get tie, so if the priority number somewhere in some situation it's tie, so at that moment we have to make comparison with the MAC address. Okay, so there's two identity, as I told. So the comparison that we have to find is the lowest bridge ID. Whose switch contain the lowest bridge ID, that we have to see, and that switch will won the election. Okay, so that switch will going to be won the election. Okay, so as I have mentioned this thing before, as I saw the before this one, like switch 2 was doing the same thing at any point. So what we call this is something which is happening in a different way. Okay, so yeah, I think this is the way, but how we can see this, is it working or not?